Hi, Spring fans. In this video, we're going to talk about data. We're going to talk about what it means to write code that uses reactive types when dealing with data stores. Okay, so we're going to go to the initializer again. We're going to create a new project. This one is going to be called data, and we'll use the defaults, except I'm going to be using Java 13. You could probably use Java 11. I won't feel terrible if you use Java 11. Java 8, on the other hand, I will know, and I'll feel bad. So we're going to use Java 13. Now, we have some dependencies that we want to bring in. I'm going to bring in MongoDB, reactive MongoDB, and I'm going to bring in R2DBC, and I'm going to bring in the PostgreSQL support here, and I'm going to bring in the reactive web support. Now, we're not going to actually use the reactive web support, but considering that everything you do in the reactive world is asynchronous, and that it's going to kick off and launch into a different thread, I can't write code using the reactive types for these data stores and not worry about how I'm going to keep the main thread running, because if there's nothing blocking the main thread, keeping it awake, basically, then the program will just terminate. So I'm going to use the reactive web support just to spin up a lightweight little web server that will just keep the Java program running. That's all. Now, let's generate a new project. I'm also going to use Lombok. Lombok's a compile time annotation processor. I'm going to use that to make short work of some of the verbosity that Java imposes. Okay, so we're going to hit generate, and opening up our project here. I have a little command line there. The command line, all it does is unzip that, and then it creates the archive, and then I run idea on the pom.xml. So whenever you see me do UAO, it's just a little Python program that just shells out, that just does unzip and idea space pom.xml. That's it. Nothing special. Okay, here's my program. Now, we're going to build an application that writes data to the database. This is not a Spring Data tutorial. It's more of what does Spring Data look like in the context of the reactive world. But what you need to know about Spring Data is that there are some common idioms, right? There's something called a template. These are objects that you can use to, with one-liner style method interactions, ask questions of the data store, do work against the data store without having to worry about the tedious resource initialization, acquisition, and destruction logic that so often burdens other data access methodologies. We're going to create a new application that's just going to talk to MongoDB. So for now, for the moment, I am going to comment out R2DBC because we don't need it yet, right? We don't actually need this in place right now, and I don't want you to wonder what that's doing behind the scenes. It's not doing anything. It's gone. We've commented it out. So all we have are the MongoDB, starters and the reactive web support, right? We've commented out the only other thing that really matters in our pretty trivial example here. Okay, so I'm going to move these PostgreSQL dependencies next to each other so they're not too far from each other. There you go. There's our types. Now, we have R2DBC PostgreSQL and the Spring Boot Starter R2DBC support. What we're going to do is we're going to start up the application. We're going to write some code that's when the application starts up, and we're going to write it to the database. The data that we're going to model is going to be called a reservation. We're going to model a record in our data store. Now, in MongoDB, a table, kind of like a SQL table in a SQL data store, that the equivalent of that in MongoDB is called a collection. Each row in a collection is called a document. So I'm going to create a document using the object to document mapper, ODM, the Spring Data reactive ODM for MongoDB. Okay, so I'm going to say private string ID. That's going to be the main key, if you will, for our record, and then we're going to create a single field, a lonesome field here called name. Okay, name. There we go. There's the basic thing. Okay, what we're going to do is we're going to persist instances of this record into the database. So we're going to say create a reactive CRUD repository managing entities of type reservation whose primary key is of type string. So we need a repository. A repository is a thing that handles the tedious, soul-annihilating data lifecycle management tasks, right? Things like read, write, update, delete, create, all these kinds of things that you want to do are supported by this interface. And that's it, though. This interface is just that. It's just an interface. There's not even default behavior that's implied in these interface methods. In fact, that's all taken care of you by the framework itself. What we get out of the box is just the interface and a number of method definitions. No implementation. We worry about that later. But when you run this code, Spring will have found your type and created a proxy and then made that type available for injection in your code base. So you'll actually be able to say inject reservation repository, and you'll get a fully formed, fully qualified, fully baked implementation of the methods that you define here. You can actually define methods here, like flux reservation find by name, string name. You can do that, and it'll automatically create a query that will talk to MongoDB and then return the results that you want. You can override the query that's provided by using a BSON query, a MongoDB BSON query, right? Like it's usually a query that looks like that, kind of. It has stuff in the middle. You can do that if you want, or if you're using SQL, you could provide your own SQL query. I mean, there's lots of different options there. If you're using Neo4j, you would use the Cypher query language. But the point is, for simple things like this, I can let the method interface do all the talking, right? I can say that I want to find all reservations whose name attribute is equal to whatever I pass in here, and Spring Data is smart enough to suss that out. We don't actually have to change it. We can just leave it as is. We also have these methods that are implied in the interface itself. These methods support things like saving, persisting, finding by ID, checking if it exists, counting, deleting, etc., etc., etc. Lots of different useful methods here. We've already introduced these types, so we don't need to revisit what publisher and mono and all these other types are. So hopefully you can see that by virtue of the fact that these are already implemented for you, and that we get automatically these query methods for you out of the box, the work of now talking to our database just became trivial. Not only can we do it, but we can do it in terms of our object model, our business logic. So now all that's left is to actually write some code to write some data to the database. So I'm going to create a sample data initializer. And this is going to be a Spring bean. It's just going to be a bean that gets called when the application's up and running. It's a callback. It's an event listener that's going to listen for when the application is ready to start processing requests. And it's going to use a collaborating object, that's our reservation repository, that we're going to inject into the constructor. Spring is smart enough to see that we've got a constructor here, and it's going to provide a collaborating reference to that object for us without us having to do anything. It'll just give us that fully formed, fully initialized reference. I could create the constructor as I have here myself manually, but I much prefer to let Lombok, another compiler processor, annotation processor, do its work. So it's going to look at my class. It's going to see that this field is final, and that final fields per the JVM language spec or Java language spec need a constructor, or they need to be initialized in the constructor, or they need to be initialized once. Like I can do this and then it's initialized and can never be initialized again. And if it sees that it hasn't been initialized and it's final, it'll create the constructor just like the one we just commented out or deleted. Now we have this bean and we have this callback, and it's the annotation that tells us that this is going to be called back, not the name, of course. And what we're going to do is we're going to write some data to the database. So I'm going to create an in-memory reactive stream, just a stream of data that we're going to initialize with some string literals. There's no asynchronous data here. It's just in time, right? So we're going to create a collection of names of people on the Spring team. So we're just going to go, some awesome people. Okay, so I'm going to add Madura. She's legendary. I'm Josh. Nice to meet you. We've got Olga. She's legendary. We've got Marcin. He's amazing and legendary. We've got, what is that, 4? We need Ria. She's legendary, amazing, right? We've got Stefan, right? There's actually a couple of them. They're both great. We've got Violetta. She's amazing, and you'll see her name in the code base for a lot of the really low-level stuff that we're going to be dealing with here in the reactive world. Marcin works on Spring Cloud. Madura, she works on Spring Boot. I cause bugs in lots of different projects. Olga, she works on Spring Cloud, Spring Security. One of the Stefans works on Spring Boot and the other in Reactor. So Stefan Maldini, who created the project that we're going to be using for everything we talk about in the next several videos, is among us. We've got Violetta. She works on, among other things, the Reactor Netty project and our reactive Tomcat integration. And who's going to be our lucky 8th name, I wonder? We've got Violetta. Who else can we add? Who else is interesting? We've got Dr. Sire, Dr. Dave Sire, co-founder of Spring Boot and Spring Cloud. Awesome, right? So there's our names, and I've got a stream of names. Okay, what I want to do is I want to visit each one of those names and write it to the database. Okay. So new reservation, and I've got a reservation, but it has no constructors. It has no fields. So I'm going to use more Lombok. I'm going to use data. I'm going to use @allargs constructor and @noargs constructor. And now I can say name sorry, null, and then name. Okay. Reservations. Good. And now I'm going to visit each one of those. I'm going to write it to the database. Now I could just say save. I could just say map and save. When I do map, you can see that it takes the results of the lambda and accumulates the return values into a container type, in this case, a flux. Well, ditto for this, right? I could do map, and then what I get is I get the result of dot save. And save, you can see, returns a mono. And so what we get is a very uncomfortable flux of mono of reservation. If you want to unpack those intermediate types, you need to use flat map. You need to use flat map over here instead of map. So flat map flattens these nested publishers. I have a publisher of reservation. I just want one publisher. So use flat map to flatten those publishers. So you say, okay, flat map, and there you go. Okay, saved, and there you go. There's my pipeline. Now, if I were to run this code as is right now, right here, nothing would happen, right? If I ran this code, nothing would happen, and that's because I haven't subscribed. Remember, we have to subscribe. So these streams are what we say are what we call cold streams. In order for them to become hot streams, you have to subscribe. So you say subscribe, and then there you go. That'll actually kick off the whole pipeline. Now, I teased apart these different lines, each line on its own, each expression on its own line, but there's no reason. I mean, you could have and probably would have more naturally, strung these things together, right? Reservation and reservations. Okay, there we are. So there's our pipeline. I can now save the data like this, but consider what's going to happen if I run this program as written right now, right? If I run this program right now, even assuming I left the subscribe in, I deleted it, but let's assume that I left it in, what would happen? Well, I'd get the same 8 records in the database over and over, wouldn't I? So right now, if I go to MongoDB on my local machine, there we go, db.reservation.drop, there's nothing in the collection anymore, right? I've deleted it, so I can't delete it anymore. If I go there, right now it's empty. The first time I run this program, I'm going to have 8 records. Second time, I'm going to have 16, right? And then the third time, I'll have 24, right? So all those records in the database. And eventually, I'll have just way too much data. I don't want to have, for our little demo examples, I don't want to see thousands of records just printing on the console there. So what I want to do is I want to tidy up a little bit. But consider that these are reactive. When you subscribe, subscriptions happen in a different thread. There's no guarantee that it's going to happen on the client thread. It can, but by default, it's probably not going to, right? So if I were to run this code, this is an overloaded method variant for the subscribe. If I wanted to run the subscribe method right now, these print lines would reflect that they're being written to different threads, right? You can use a logger, for example. You can say, let's create a logger and just say log.info. Okay. So now we have log.info. Log.info is going to reflect that we are running on different threads. We don't know which one. It's not the main thread is the point. So the point is, when you run this, there's no guarantee that this is all going to finish before you try and do other things. So I can't just do this. I can't just say delete all, because delete all returns a publisher, and I need to subscribe, right? And I need to finish all the subscription before I do the next thing. This can get tedious, and this is an exercise in multi-threaded programming. So instead of trying to solve it in those terms, just use the API, use the operators. So instead, I'm going to say, hey, delete everything, and then find all the data, and then write it all out, find it all and log it out. So we're going to delete everything, save it, save new records, and then find everything, and then finally subscribe to the results, like so. Okay, there's our entire pipeline. Good. Let's run this. Okay, did it work? Good stuff. There's our data. There's our 8 records on the console. So we're using MongoDB here. MongoDB is a good fit for a lot of different use cases. It's a document database, and it's you can see that we have these interfaces that allow us to describe data that works with MongoDB. MongoDB is all about denormalizing your data structure. So instead of having relationships that reference each other, which you can do, instead it's very common to have nested objects within your data structure, right? So if you want to have a more complex graph for a data document, just put it in the same record, right? Just duplicate it. It's fine. The benefit is that you get performance out of that. There's some interesting things that you can do with MongoDB. One of them is it's not called a continuous query. It's a feature that you can use in MongoDB that lets you say, hey, when this data is available, I want that data to be given to me. Instead of me having to pull or ask again, just push it to me. Instead of me having to pull it down, the database will push it to me. That feature is called tailable cursors. Okay, this is a very natural thing to do with a reactive API. The API can give you a publisher of type reservation, and as soon as the data is available, it'll start broadcasting it to you, so you don't have to constantly pull the database. Okay, in order to do that, you have to actually start up your database in a replicated set mode, and I haven't done that, but it would be very trivial. You know, if you wanted to do something like this, you could say tailable, and that's it. Suddenly, as long as there's data in the first result set that comes back, then as soon as there's new data, you'll get the updates, right? Assuming you've started your MongoDB database in that mode. This is a feature that just maps itself. It's unique to MongoDB. Well, it's a feature that is called tailable cursors in MongoDB that is very similar to continuous queries and other distributed data grids, things like Apache Gemfire, right? The open source Gemfire project. These are things that you can use in those database technologies, those data grid technologies, but it's not a very common thing to have in a database. So it's very cool that it's just so natural. It so naturally maps to reactive APIs. I like MongoDB for a lot of different reasons. It works, it scales. It's certainly made our work very simple here. In the next section, we're going to talk about SQL.